Hi everyone, this is Mr. Nam, and today I'm going to be going over my 7th grade science kids, your assignment for Friday, September 25th, in case you missed it. And today we talked about pressure. So this PowerPoint is assigned to you in Google Classroom, so feel free to open this up to work on it as I go through the PowerPoint. But so for your do notes today, I want you typing in the notes or either on the slide directly as the model below shows what state change happening. How do you know? Okay, so I know the state change happening is blank and why. You can disregard this because this was due, that was due the other day. Okay, alrighty guys. So we went over the do now. Now let's go to your scientist of the day. Baruch Benacerraf was born in 1920 and died in 2011. He was an American immunologist born in Venezuela to Jewish parents from Morocco and Algeria. He moved to the States in the 40s, graduated from high school and college, and got his MD from the only school to admit him since he was Jewish. He was a medic for the U.S. Army, eventually joined Harvard Medical School for 21 years. He also won the Nobel Prize in 1980 for discovery of proteins on cells that allow the immune system to know itself from non-self. Pretty amazing stuff. Alrighty, guys, then we went into breakout rooms. You know the expectations. But what you're doing is you are creating a model based on your breakout room number. So all students are going to open the breakout room slideshow, which is this. Okay. And the students with the most files will share their screen. You're going to find the slide that matches your breakout room number. Discuss the given scenario. What states are in the particles in the before and after model? Label them as you'll see here, and I'll go over in a bit. And discuss what the particles in each picture should look like. Create the models using the particles, arrows, and vibration lines available in the particle and arrow bank. So if we go to slide 7, this is an example. Fog on a bathroom mirror. We know first we have before and then after, which is condensation, right? We have a gas that turns into a liquid. As you can see, this is how I've demonstrated a gas and a liquid. So depending what group you are, you have different situations, okay? You're showing the particles and how they're interacting with each other. If you're group 1, you are evaporation, group 2 is melting, group 3 is sublimation, group 4 is freezing. If you're working on this on your own, just choose one of them and fill that in for yourself, okay? And the learning target today, guys, is I will predict the change in pressure in a closed system based on change in particle motion or state. So first off, what is pressure? It's a push or force against the surface. The weight of the air in Earth's atmosphere is what we call our atmospheric pressure, okay? There's some academic language that I want you to know. First is temperature, which is basically the measure of kinetic energy of the particles in a substance. The hotter something is, the more kinetic energy there is, right? Another academic term is closed system. So a physical space or container that does not let matter or particles out. It's a system that is closed, okay? Volume is the amount of space an object takes up. And so your independent work or activity today, guys, is you're going to open the simulation here, okay? And it's going to pop up that simulation. Oh, let's go back. You're going to click on the second box, phase changes, and take a couple minutes to play around and get to know the simulation. Then you're going to click on the neon and reset. Neon and then reset. So if I do that, when it loads, phase change, neon, reset. Okay. And then you're going to slowly heat the solid neon particles to about 25 Kelvin. So let's heat it to about 25. See how I can do this? Oops. Let's kind of slowly raise it. Oops, let's go back down. So I'm going to reset this because I kind of messed up. 25 Kelvin. Okay. And so now that I'm at 25 Kelvin, then the question that I'm answering is, watch what happens when the pressure increases above 0 atmosphere. Oh, it's starting to rise, right? So then you're going to answer the question on the next slide. Right here, these questions are pretty straightforward, but this is just how you set up the simulation, okay? Once you're done with these questions, guys, there's an exit ticket on the next slide. It is not a Google Forms today. You are just answering this question. and using the sentence starter to answer it. So does the container A or B have a higher pressure? This explain by describing how the difference in particle motion causes this higher pressure. Like always, guys, if you have a question, I am always here. If not, have a fantastic weekend.